Okay, so smart and tablet phones are said to be the concepts, and these concepts possess some attributes like size, color, screen type, shape, and their values are for size it is small, comma large, color it is gray, comma black, and screen type it is flat, comma folded, and shape it is square, comma rectangle. Okay, and now these are all binary valued attributes, right? So you can represent a concept C with its attributes x1, x2, x3, and x4, or collectively you can have a capital X, where in turn this capital X is a record or a tuple consists of four attributes. Okay, and this is an example: tablet equal to large, black, flat, square, where size is large, color is black, screen type is flat, and its shape is square. Then it belongs to a concept tablet. And at the same time, if it is small, gray, folded rectangle, then it belongs to the class smartphone, concept smartphone. Okay. And with this binary valued attributes, you can generate 2 power d instances, and the number of possible concepts that can be generated out of this are 2 power 2 power d. So totally 2 power 16 possible concepts can be generated with this example. Okay. But for the multi-valued, this 2 power d is not possible, right? And there is a concept space, and you cannot search or you cannot see the entire concept space. So you are focusing on only a specific region of that, and this specific region is said to be the inductive bias, or this is called as hypothesis space, or otherwise this is called as target concept. Okay, right. You can also use conjecturators, and for example large and black and flat and square, then it is tablet. And out of these 4 attributes, the important one are large and the shape square. Okay, if it is square, it is tablet. If it is rectangle, it is a smartphone. So these two are more than enough to uh, uh, say whether tablet belongs to a concept or not. Okay. And there are 2 different notations that are used in this hypothesis. And this is said to be a hypothesis where all attributes are marked with a question mark, which means it belongs to a mobile universe. At the same time, whirlpool, comma 0, because it does not belongs to a mobile universe. That's why the concept of whirlpool is marked as 0, since we are discussing only about mobile universe. Okay, right. So this is the sample data, and from sky to forecast is the independent variable, and enjoy sport is the dependent variable. And when you look at this dependent variable, you can say that this is the concept of xi. You can have x1, x2, x3, x4. Don't confuse this x1 to x4 between the columns. I'm not, this x1, x2 are not columns. Okay. These are the tuples, the data points. This is x1, this is x2, this is x3, and this is x4, and you have attributes. Okay. And if it is sunny and warm and strong and warm and same, then the dependent variable says that he can enjoy sport. So totally how many possible instances are there? 3 positive instances, give instance there. Okay. And if you want to search something, then you can go for an algorithm, find S algorithm, where S stands for search. Okay. And in this algorithm, only the positive instances are considered. Okay. Positive instances are considered, and we are doing sort here. Okay. We are moving from what a general to a specific ordering. Okay. Actually, we have to do general to specific ordering as well as specific to general. Both are possible, but in case of find a cell algorithm, we are moving from a specific ordering to a general ordering. Okay, specific ordering to general ordering, where by considering only the positive examples. So let us look into the example first so that you will understand what. Yes. So it has got an algorithm. Let us look into the steps. The first one is initialize a hypothesis H. Okay. Initialize a hypothesis H. Identify positive example and you check for the attributes. You check each and every attribute between the hypothesis and the data instance. Okay. Find out whether there is any match or mismatch between the attribute values of the hypothesis and the positive data instance. Okay. So if that
Ma'am, not audible, ma'am.
Okay, had some connectivity issue. Let me share the screen again. Okay. So this is the initial hypothesis. And these are our data instances. And this finders algorithm considers only the positive examples. Okay. So as per the algorithm, uh, you are initialized this one as a as a specific hypothesis, and then you are considering your first data instance as the hypothesis H1 since it is a positive sample. So this H1 equal to sunny, warm, normal, strong, warm, same, which is similar to this X1. Okay. Now you have to compare this hypothesis H1 with the next positive data instance. And this is the next positive data instance, and you have to compare H1 with X2. Have to compare each and every attribute values and check whether there is any match. You replace the value of the attribute by a question mark, which means you are moving from specific to a generalization. Okay. And here the value of the first attribute is sunny. And here also the value of the first attribute is sunny. So no issues. Consider the same sunny again in your next hypothesis. And in the same way, compare the second attribute value warm with this uh, second data in value. It is a match. So consider the same. Now when you look at the third one, here it is high and here it is normal where there is a mismatch. Okay. If there is a mismatch, which means this is very specific. In case X2, the third attribute value is very specific, stating high for a positive data instance. At the same time, your hypothesis also consists of the value normal for a positive instance. Okay. In order to generalize it, uh, you don't consider the value high, you don't consider the value normal, instead go for a generalization. So use a question mark there for the third attribute value. Then considering the fourth attribute, it is strong issues, have the same value. Again, warm, use the same attribute value. And the last attribute value is same in both hypothesis as well as the new data instance. So you use the same value in your upcoming hypothesis H2. Okay. So now this H2 is the new hypothesis where you have moved from a specific hypothesis to a general hypothesis by replacing only the third attribute's value, where in the hypothesis it was normal, and in the um, new data instance it is high. Since both values are different, you are doing a general question mark. Okay. Now can you compare this hypothesis H2 with the data in C? You cannot compare because this is a negative instance, and our finders algorithm consider only the positive cases, right? So better you compare H2 uh, with the next attribute X4. Okay, actually here what they have done is, since this is negative, you don't consider this example. So your H3 is same as your H2. Okay, that's what they have done here. And now you compare your H3 with this new data instance X4. Since the X4 is a positive data instance. So when you compare this, sunny, no change, warm, no change. Here it is question mark and here it is high. So you follow the same general one, question mark, and then the fourth attribute is strong. Here also strong. So consider the same. And when you look at the fifth attribute, the values, since the values for the fifth attribute is different in your hypothesis as well as in your new data instance, you make it generalized by replacing the value with a question mark. Again, when you look at the last attribute, here it is same in the hypercent. In the data instance, the value of the sixth attribute is changed. Both are different. So again, try to generalize it by using a question mark. Further, you don't have any samples in the data set, so you can stop here. And this H4 is your general hypothesis. So now you have moved from a specific hypothesis to a general hypothesis, where your general hypothesis states that the first attribute, what's the attribute? I think it is sky temp. Your first attribute should be sunny. Your second attribute should be warm. Your third attribute may have any value. Your fourth attribute value should be strong. Your fifth attribute value may be anyone, and your sixth attribute value may be anyone. So let us not bother about this third, fifth, and sixth attribute value. At the same time, your first attribute should be sunny, your second attribute should be warm, and your fourth attribute should be strong. So if your hypothesis and second warm attribute even your so not be your one is to so we are using another space termed as Gaussian space. So before that, I have planned for an activity. You can note down the data quickly. Okay. Yes. Students, please note down this data set quickly. So this is your today's activity, and you have to apply a finders algorithm. You have to solve it manually, and then you have to implement it using Python and check whether both the results are same. And you just put everything in a Word document, or you can solve this in your notebook using in your handwriting. You solve it, and you can execute a Python program. Better execute it in Colaboratory, and you can share your Colaboratory link, or you can paste your Colaboratory link in a Word file where you have solved this problem, and you can post it. Okay. So you all should complete this activity. So please make a note. And here you have 5 features: origin, manufacturer, color, year, type. Okay. Origin have 2 values, Japan and USA. And manufacturer, you have Honda and Chrysler. Color, blue, green, white. Then you have some years. Then type, whether it is what this ECO stands for economic, and SPO stands for sports. Okay. And these are your class labels: 1, 2, 3, 4. You have only 4 positive instances, and rest are negative instances. So to start with, you have a specific hypothesis. Then you consider first positive data instance as hypothesis 1, and then you can compare hypothesis 1 with your second data instance. If you want to generalize, you can generalize. Like that, you proceed until you reach the last hypothesis. Okay. Have you noted it? Shall we move on to the next one?
Yes, ma'am.
So the next one is what? Candidate elimination algorithm. So you know what is general hypothesis, what are specific hypothesis, and they have introduced a version space here. Okay, I'll tell you what is this. It's an intermediate space. That's it. So listen. You have a what uh, specific hypothesis where you are using this phi symbol. Okay, specific hypothesis, and you have a general hypothesis where you are using a question mark. Okay, so they have introduced a version space in between this boundary as well as this specific boundary. Okay, so they have introduced some version space here. This is what version space, the thing which lies in between the specific version and the uh, sorry specific boundary as well as the general boundary. Okay, I'll tell you with an example, right? Imagine you have a mm, mobile phones. Okay, same iPhone starting from 5s to 7s, 8, 11, then what, Pro. So all versions are here. Okay, so now uh, then you are considering only a subset of this version where your subset consists of iPhone uh, version above 7. Okay, above version 7 is there in the subset. So this is your hypothesis space. This is your hypothesis space where in your hypothesis space you have all iPhone versions. Beginningல இருந்து இப்போ வரைக்கும் என்னென்ன versions release ஆயிருக்கோ, so all versions are available in this hypothesis space. Now you have considered the versions which are greater than 7. Okay, and in between these two you have a version space. Okay, and your version space consists of say 8, then 8 plus sada, 8 plus, then 11 plus. So such versions you have. Okay, the thing is whatever available in the version space should also lie in the hypothesis space. Again, it is like a subset only. So இங்க இருந்து ஒரு சப்செட் இங்க எடுக்கிறோம், அப்புறமா இங்க இருந்து ஒரு சப்செட் இங்க எடுக்கிறோம். இந்த intermediate subset is said to be the versions. Okay, and, in candidate elimination algorithm, wherein finders algorithm you moved from a specific boundary to a general boundary, from a specific version to a general version. Okay, but here we are moving in both directions. You have to move from specific version to general specific space to a general space in case if it is a positive example, and you have to move in the reverse direction if you encounter a negative example. Okay, so this is a new thing introduced in this candidate elimination algorithm, just to consider the what negative examples. Wait. What's the time now? Almost time. ஒரு சின்ன brief தரேன். You you read it from your textbook and you come to my class. Okay. So look at this, from a specific boundary to a general boundary when the algorithm encounters a positive data instance, and have to move from general to specific when it encounters a negative examples. This is the idea behind candidate elimination algorithm. You don't panic looking at this big difference so easy. For the same example only, this candidate elimination algorithm is also constructed. So shall we stop here or shall we continue? அடுத்த யாரோட அவர்? Okay. So
Lab, ma'am.
only only 2 minutes more. With that 2 minutes, if I start, I think I cannot conclude.
Ma'am, voice break ஆகுது ma'am.
Okay, so I'll explain this in the next class. Adiyama, சரிமா சரி. I'm in college and I'm using our college internet only. So thank you, students. You can connect for your laboratory. I too have hour in the next class. So let us meet in the next class to discuss about this candidate elimination algorithm. Okay. Thank you.
Thank you, ma'am.
Thank you. Thank you.